So we use the second one. Okay, we use the second one. So in exam, they'll ask, how do you get gravity? So show the apparatus I show you now. You must measure, use the two photo gate. Photo gate is a electronic timer. Like it's a very sensitive device which has sensor. When the object passes the sensor will on. So you give a very accurate time. It's a substitute of stopwatch. Stopwatch got one big problem. What is the problem of stopwatch? You have a very significant reaction time. So timer don't have that long. So that's why we use timer. Okay. So then we plot h versus t squared to find the gravity. Okay, this description you have to know. Yeah, vary the height, measure the time. Any question from here? You must know how to find gravity by using experiment. Okay. Okay. So now today's something new is this part, projectile motion. Okay, this is totally new. And an object is launched at a diagonally with a certain speed, like this bike. The bike will go up and will come down. You're going to make a parabolic path. This is called projectile movement. Projectile movement. What is so unique about this type of movement? This is a two-dimensional movement. We call it two-dimension. Why is you say two-dimension? What I say two-dimension? Because it moves horizontally at the same time it's moving vertically. So this is a two-dimension movement. Okay. So we're going to solve this projectile movement. For example, let's say you launch the motorcycle was launched with a 30 meter per second diagonally, makes an angle of 30 degrees. For example, okay, it launched here with 30 meter per second, okay, and it makes let's say from horizontal it makes an angle of let's say 20 degrees, okay. So it goes up and come down. So we want to find what is the maximum height it can achieve from the launching point. What is the maximum height it can achieve? You want to find that. You want to find what is the maximum range it can cover, and it fall back to the same displacement. What is the range? We call it range. And you want to find what is the total time it take to land back to the ground. These are the factors we're going to look for. S, H, T, something you SUVAT again. Okay, SUVAT again. But the problem here is this is two-dimensional movement. This is two-dimensional movement. The four formula you learned last time is only for one-dimensional. It have to move straight. The object have to move straight. Then only you can use that. E equals u plus at, s equals to u, t plus half at squared. All are for one-dimensional. But this is two-dimensional, Okay. So how we want to solve this? So that's today's lesson, important part. Okay. So let me go to the whiteboard to explain this. Okay. You can take a piece of paper to write this, but first understand it, what I'm trying to write. Whiteboard. So it's totally going to be writing. Okay, let's say I want to launch with the initial velocity, I label it as u. Okay. After launch, it comes down. Okay, it comes down. The velocity is moving at after a time t. After a time t, we call it as v. Okay, v. Okay. So now the angle from horizontal, we label it as theta. Okay, we label it as theta. Okay, this initial velocity, right? We can resolve to their components. This u, we can resolve to two components. Okay, like last time your force, you can break into components, horizontal component, vertical component. We do the same thing here. The initial velocity, we break into components. Horizontal component, and vertical component. Okay, the horizontal component, we label it as ux, something new. We put it as ux. The vertical component, we label it as uy. Okay, ux, uy. Okay. So now the ux, when you resolve down, When the you resolve down, the ux will be what? U sine theta or u cos theta. Okay. I think I don't know whether I remember, I told you or not. When you close angle, when you go down, you close angle or open angle. When you close it, go down. You go down, you close the theta, you know, like you're closing the theta. When you close, you must use cos. It's a shortcut. It always works. Okay, don't worry. When close the angle is cos. The ux is u cos theta. The uy will be u. The theta when you bring up, you are like open the theta. When you open the theta, it's always sine. It's u sine theta. Okay. Okay. So this is components ux, uy. Ux is what? U cos theta. Uy is u sine theta. Okay. Let me concurrently go ahead with one example. One example with this. Okay. One example. Okay. Let's say I launch an object with a u 30 meter per second. Okay. I need someone to calculate for me. Okay. Try to have a calculator with you. Okay, so I launch horizontally with 30 degrees. Okay, I launch 30 degrees. Okay, when the object launched like this, imagine there is a two camera was placed here. Camera. We want to take the picture of this object when it launched. This camera, the first camera, is allowed to move vertically up. Okay, the second camera is allowed to move horizontally. Imagine. And the object is somewhere here, let's say somewhere here after launched, this first camera will be positioned here to take the vertical picture. Okay, the object is at the top, the vertical camera will be at the top, and the object come down again, come down again, the camera will return back. So how the vertical camera will move? It will go up, then later it will come down again. Okay, that's the vertical camera movement. Okay. The second camera, imagine, this all our imagination. Okay. The second camera, imagine like moving horizontally. So when the object is up here, the camera will be here. And the object is finally go down, the camera will reach here. So how the second camera move? From the initial point to the final point, it will move this way. Okay. Okay. The object experienced 2D motion, two-dimensional movement. Okay. The camera 1 and camera 2 moving what dimension movement? 1 or 2? Anyone? The two camera move one dimension movement or two dimension movement?
One.
It's one dimension movement. Okay. The camera 1 is representing the vertical movement of the object. Okay. The camera 2 is actually exactly representing the horizontal movement of the object. Okay. So here we dissect, okay, I just use the word dissect biology. We dissect the two-dimensional movement into 1D. Okay. Why we break them into 1D? Why we break them into 1D? Because we can use the SUAT formula. Okay. The four formulas can be used because that four formula only can be used for 1D. Cannot use for 2D. You don't have one for 2D. Okay. So now tell me the camera one, you see the actual object is moved diagonally with 30 meter per second, you know. Camera one, when this object move diagonally take off, the camera one start to move up. The camera one speed, the U1 speed will be more than 30, less than 30, or same as 30. Anyone? The U1 camera when take off, when the object is moving up, the U1 will move upward.
Yes.
The speed of the camera U1 will be more than 30, same as 30, or less than 30. What do you think?
Less.
The object less than 30. Those you need to imagine this because this object is just taking off diagonally now. Diagonally with 30 meter per second. This camera going up, it should be less than 30. Okay. So this U1 is actually the UX here. Sorry, the UI here, UI, vertical speed. The U1 is actually the UI. Can you find UI for me? It's 30 sine 30. Okay. The vertical camera speed will be, this one I know, it's 15 meter per second. Sine 30 is up. 15 meters per second. So what I'm trying to tell you here, when an object is moved 30 degrees, 30 meters per second, 30 degrees from horizontal, the vertical camera will take off with a speed of how much? 15 meters per second. Take 15 meters per second. Okay. So like it'll go up with 15 meters per second. Okay. The second camera, U2, what is its speed will be? More than 30, same as 30 or less than 30? The second camera. It also be less than 30. Both will be less than 30. U2 is actually the UX. Okay, in this diagram, UX, the horizontal speed of the object. So how much the speed the second camera will move forward? 30 cos 30. Okay, someone please help me to calculate. Give me 3 significant figure. What's your answer? 30 cos 30. Anyone? 30 cos 30. 3 significant figure. Plus
26.
26.0. 3 SF.
Yes.
Yes. Okay. 26.0. Okay. Okay. So this is the speed of which camera? The second camera, you know. Okay. Okay. Good. So now we are ready to analyze this movement. Okay. What do you want to find? What is our main question? We want to find first. We want to find the total time. You want to find total time. Okay. You want to find total time. Second, what do you want to find? You want to find the maximum height. You want to find the maximum height. The h. You want to find the h. Okay. Third, what do we want to find? We want to find the range. Okay. We want to find the range. This is your range. Okay. This is your range. This is your range. Range. Okay. So to find this, remember, first what you have to do is collect the information vertical and horizontal first. Okay. You have this is a two-dimensional movement, you know. So you have two group of set of reading. One is vertical, one is horizontal. Okay. Vertical component is actually the one represented by the first camera going up. Its qualities. Horizontal is actually the all the components, the initial velocity, the final velocity of the second camera. Okay. Okay. First thing you have to write here is vertical camera. The UI is what? UI. All we put Y. We put symbol Y, because vertical what? Vertical we put symbol Y. So last time you only write initial velocity as U, but when it comes to projectile motion, you have two types of U: UX, UY. Okay, and of course actual U. Actual U is the actual speed of the particle. Okay, UI will be what? Always U. What? U sine theta. Always remember. UX will be always what? U what? U cos theta. Okay. Okay. So this is what you need to write first. Okay. Now this is important. Next, AY. Okay. AY. What is AY? AY is when the object is thrown up and come down. When this camera when moves up, okay, what will happen to the speed of the camera? Decreasing, increasing, or move with constant speed?
Decreasing.
Should decreasing. You see, if anyone can imagine the object is going up and up and up and slow down, then what happened?
Reach your top tip. Okay.
Reach the top. Sorry. Okay. Something wrong. Okay. So reach the top. When it reaches the top, I think the vertical height rises further. When it goes up, is shorter. Okay. Earlier, the vertical height rises a lot. And go to the top, the vertical height rises. The vertical height, the vertical height gets shorter. So this velocity camera, when go up, you need to rise only a little. So the velocity become smaller and smaller. So the AY value, they say, is exactly negative 9.81. Scientists found that through experiment, the vertical camera is exactly as an acceleration of negative 9.81, like a free fall, AY. And this AY value does not change. It always, AY is negative 9.81, remember? Okay, it's a free fall for the first camera. Okay, because now vertically, you need to decide upwards as positive or downwards as positive. I already told you the earlier class, I want to choose upward as positive. I'm going to take upwards as positive. Therefore, because gravity acting down, the AY I take negative 9.81. Okay, so I'm stick with what? Upwards as positive. Okay, so AY is negative 9.81. AX, okay, AX is the acceleration of the second camera. When the object is going up and come down, the second camera move horizontally. How's the speed going to change for this second camera? When you take the picture of the object going up and come down, they found that the AX is 0. It's also fixed. Horizontal acceleration, it seems 0. They ask why AX becomes 0? Because see, when the object launched, when the object is at the top or anywhere, and the object, let's say somewhere here, what is the only force acting on the object? Anyone? What is the only
Upward.
force? What type of force acting on the object? The only one force. The weight. Only the weight acting down. Any other force? Do you have any other force? It already launched what? It already come out from the launching point. After launched, it's act of nature. The only force is the weight. The weight is the one pulling it down. That's how I make a projectile movement. So the only force acting is weight. We neglecting air resistance. We neglecting air resistance. The only force acting down is the weight. So the weight is exactly acting down. What is the horizontal component of the weight? mg, if you derive horizontally, how much the horizontal component of the weight? The fx, we call it, will be, anyone? Will be 0, right? Because 90 degrees one. 90 degrees one. mg, you resolve 90, you close the 90 degrees angle. mg, you resolve horizontally, you close the angle, right? Close the angle, you use cos. So mg cos 90 will be 0. So the fx component is 0. So there is no force pushing it forward. The horizontal force is 0. Because the horizontal force 0, therefore horizontal acceleration ax is 0. So ax is 0. Okay, now you understand why ay is negative 9.81. Because vertically, the force pulling it down is mg, exactly mg. So mg equals to ma, that's the net force. So a you get, the ay you will get what? Exactly g. It's actually negative g lah, because negative we put based on the direction choose for. Up positive, so down is negative 9.81. Okay, class. Any type of projectile movement, ay always negative 9.81, ax always 0. Okay, good idea, eh? Okay, now as we proceed, you want to find total time. You want to find what? You want to find total time. The first idea you want to find total time. To find total time, you want to use the Force-Suvert formula. How many information you need? 3, right? You need 3 information, right? SUAVT, SUVAT. You are looking for what now? You're looking for total time. So you're looking for total time. You need 3 informations out of this form. SUVA. You need 3 informations. Okay, now total time you can find from vertical or horizontal. Either one can. Why? You see, total time taken for this object to go up and down is the same as time taken for the first camera to go up and down, right?
Oh, yes.
Same as the second camera to move from here to the final point, right? So the only quantity which is same for all three of them is the time, So total time you can find by using a vertical component or the horizontal component. But the only thing is which side you got three informations. Okay, in this case now, which side you got three informations? Do you have any side three informations? Both side got two informations only. You know UI, you know AY. You know UX, you know AX. Okay, total time, you have one hidden information at one side. Which one? You have one hidden information. I think you can go for vertical. Vertical, there is one information is hidden information. You know, I'm focusing to vertical, vertical. You know A, you are looking for time. Okay. Do you know V or do you know S? Indirectly. You're looking for total time. Anyone? When the first camera go up and come down, displacement is how much?
Zero.
Zero.
Oh,
So the hidden information is what? Sy is 0. Now I have to put Sy because we have two components. So yeah, this is the hidden information. Sy is 0. You know UI, you know AY, you're looking for time, Sy is 0. You can find total time. Okay. Okay. So use this information. We go back to this example. Go back to this example. The object launched 30 meters per second, 30 degrees from horizontal. It goes up and come down. Can you find first total time? Find the total time. Okay. So you go vertical or horizontal. You have to decide first. You going for vertical. Okay, going vertical. So UI is how much? UI is 15. AY is how much? UI we found is what? UI is 15. AY is how much? Anyone? AY is negative 9.81. Okay. Then the hidden information. Your SY is how much? SY is 0. Okay. Can you find the total time? What formula do you use? SUA, you're looking for T. So use a formula without V, right? So what formula is that? S equals to UT plus half AT squared. Okay. Half UT plus half AT squared. Okay. Okay, please class, can you work out for me the time, please? Put all your information, get me the time. Give you 1 minute for you. Okay, get me the time for me. What is the time taken? Put UY is 15, AY is negative 9.81, SY is 0. So what is the total time taken? How many seconds? Give me 3 significant figures. Hey, class, I think someone's phone, I think, quite close by. Because the audio is like, okay, so I got in the chat, okay, the answer. So 3.06 seconds. Okay, good. So 3.06 seconds. Okay, I think makes sense. So 3.06 seconds. So remember, if you throw an object with 30 meters per second, makes the 30 degrees from horizontal, if no air resistance, the object eventually will hit the ground back after 3.06 seconds. Okay, this is definitely correct without errors. Okay, these all are without errors. So 3.06 seconds. Good. So how are you able to find the total time? Although it's a two-dimensional view, we break them into two components, SUY, UX, vertical and horizontal. We use the vertical component because of what? We know SY is 0. So we have three information vertical, so we can find the total time. Okay. Okay, good. So now I want you to think, how are you going to find the second one? Second one. Okay, now 30 meter per second, 30 degrees, the total time is 3.06 seconds. What is the maximum height it achieved? What is the maximum height it achieved? If you launch 30 meter per second, 30 degrees, what is the maximum height it can reach before it comes down? First, you need to decide. You want to go vertical or horizontal? Which one experienced vertical height? Vertical or horizontal? The vertical component, right? So you have to go for, again, vertical camera. You have to go for the vertical camera. Okay, this is the one experiencing the maximum height. Okay, so you're looking for what now? You're looking for SUAT. In the SUAT, you are looking for which information now? You're looking for displacement, S. You're looking for displacement because maximum height is S what? Displacement, SY. Do you know three informations? So we go for vertical. Do you know three informations in vertical? You know UY, you know AY. You're looking for SY. Do you know the third information?
Time.
Time, yes, time. Time, you know, but this time is total time one. So the time you're going to use to find the maximum height, how much?
Half time.
Half of it, good. The 3.06 divided by 2. You get the time taken for it to reach the top. Good. Yes, time. But can we use V? Do you know VY? Do you know VY? When the one go to the top, when this camera go to the top, what happened to the VY?
0.
0. Yes, good. That's another information one. VY is 0. You can use VY also. Okay. UY, you know, AY, you know, VY is 0 when you find maximum height. Okay, because here no space, I want to rub the, what do you call the time. So let me up and continue there. Where's I rub this. Okay. So remember the maximum time is 3.06 seconds. Okay. Okay, so yeah. Okay, so now let me get back. Okay, so now what are you going to look for? Second one, we're going to find the maximum height H. Okay, so we go for vertical. We still go for vertical. So your UY is, is 15, and AY, is negative 9.81. Then now I think I prefer go VY. VY is 0. You can go time, but let's say you time earlier calculated wrongly. So you're going to be a chain reaction. So I think VY is 0 best. Okay. You're looking for what? You're looking for SY. Looking for SY. Okay. So what formula do you use? Come on, calculate for me. Anyone? Now you know. You can use no SUAT. Use the formula SUAT. Tell me what is the answer for the maximum height. What formula do you use? Anyone? V squared goes to U squared plus 2AS to be used. But now please decorate everyone SY, BY, UY, AY, SY. It's vertical component. Okay. So get for me SY, please. Someone. How many meter? Okay, 1 minute for you. y 0, y is 15 squared, 2, a is negative 9.81. Okay, good. Find sy. So sy is 11.47 meter. Okay, good. Is it everyone got 11.47? Is it 11.5? You go for 3 SF, huh? All of you got 11.5. So 15 squared plus 2 negative 9.81 sy. Find the sy. Okay, so 11.5 meter. So anything launched with 30 meter per second, 30 degrees, the maximum height it can achieve is 11.5 meter. Okay, we found 11.5 meter. How we found it? By relying to vertical component, uy 15, ay negative 9.91, but maximum height, the hidden information is vy 0. Vy is 0, so we find sy. Okay, 11.5 meter. So total time and maximum height, we use the vertical component. Why we didn't go for horizontal? Because horizontal not enough information. To make use of the Force-Webb formula, you need to have 3 information. I think vertical able to give us the 3 information. Total time hidden information was sy was 0. Sy was 0. Maximum height hidden information is vy 0. Remember. Okay, now totally yours. 1 minute. I believe you can have an idea now. How do you find the third one? Can you work out for me? What is the range? What is the range of this projectile movement for this example? Decide, do you go for vertical or horizontal? Whatever component you use, you must have 3 information. Go vertical or horizontal?
Horizontal.
Of course, horizontal. You can't go for vertical because only the horizontal camera displacement is the same as the range of the object. So you have to go for horizontal camera. So the horizontal component, do you have 3 information? You know ux, you know ax. You're looking for what? You're looking for sx. Sx. You're looking for sx. Okay. You need another one. Yeah. What is another information you know? Which you already know now.
Time.
Time. Good. You know the time. Time is the only culprit transferable. This time going to give lots of problem. It's just hiding inside the vertical, but vertical and horizontal the same time. So you already know the time. So the time is how much you got earlier? 3.06. 3.07 is it? I forgot.
06.
06 seconds. Yeah. So to find the range, the time which you counted earlier to be used. So please calculate for me the range. Ux, you know, ax, you know, time is 3.06. Can you find sx? Okay, 1 minute. Come on. Give me the answer. Drop this. Okay, so you're looking for what? You're looking for sx. Sorry, it's quick. You're looking for sx, range. Okay, range. You're looking for range. Okay, so you know ux, you know, ax, you know, and t, you know. So find the formula sx. So what formula use? Sx equals to, yeah, I got the answer. Uxt plus up at squared. Okay. But here for x, one good news is ax is 0, you know. Ax becomes 0. So this entire component will become 0. So we can modify the equation to sx equals to uxt only. So therefore you get your answer. So the answer is what? 79.6. Okay, let's see. So 79.6, everyone. Get it from the chat. Good. 79.6. Okay, so this is your range. So the range it covers. Okay. So conclusion, if you launch 30 meter per second, 30 degrees, the time you're going to reach down is 3.06 seconds. The time was 3.06 seconds. The maximum I reach is around 11 point something. And the range you're going to cover is 79.6 meter. So we can analyze the projectile movement just by using SUAT 1D by splitting the 2D to 1D, as I did here, like a camera, vertical camera and horizontal camera. But in exam, don't write about camera. It's just an imaginary object. Okay, you use the vertical component and horizontal component. Okay, any questions so far before we proceed to the next level? Okay, this is the primary one. Okay, so remember, whenever you do projectile movement, U, Ux, Uy. After it launch for a certain height, the velocity we consider as V. Okay. Okay. So now the next level is, I'm going to add fourth question here now. Fourth question. Okay. Which I never show you earlier. Fourth question. Total time, height, range. The fourth question I'm going to ask is find, okay, find what? Find the velocity, find the V of the object, find the V of the object after after time t exactly 2 seconds. Exactly what? Exactly 2 seconds. This is the next question. Okay. Let me rub this all. Okay. Rabia. Okay. We done this. Okay. Okay. So now anyone can predict how do you do the fourth one? Find the velocity after t is 2 seconds. Okay. I go to the diagram. I need to add some new quantities now. Okay. Okay, the new quantities is, let me go up. Okay, so now in the diagram, I'm going to add a new quantity. We want the velocity. We are looking for the V. Yeah, we are looking for the V at 2 seconds later, after launch 2 seconds later. Tell me, at 2 seconds, the projectile, is it already past the first half of the movement? Is it in the first half of the movement or the second half of the movement? For this question, the 30 meter per second, 30 degrees. After it launched, at 2 seconds, I want the speed. Is still in the first half of the movement or the second half of the movement? Anyone? Because the total time is how much? 3.06 seconds. I want the speed velocity at 2 seconds. That means, is it in the first half or the second half now? It's in the second half. It's in the second half because more than half of this time. Okay, half of the time is first half. This 2 seconds is more than half. So it's at the second half. So go back to this diagram here. It's at this second half. Let's say somewhere here. Okay, we want to find the V. How do you find the V? Is you need to find the component of Vx and Vy at that point. You need to find the Vx and Vy at that point, at the time 2 seconds, so that we work out the V. Okay, how Vx, Vy can give you V? How Vx and Vy can give you V? Because Vx and Vy are components of V. So how Vx, Vy, V related? Anyone? How Vx, Vy, V related? It's a Pythagoras theorem. The Vx horizontal component and the vertical component going down for this case, Vy, is actually V. Okay, it's V. This is how they related. So remember, V squared is same as what? Vx squared plus Vy squared. They are related. the components can give their actual value, because they are components. Vx squared plus Vy squared is V squared. So the only way to find the V is finding their components Vx and Vy at time 2 seconds, because our question is want to find V at 2 seconds. Okay. Okay, so how do you find Vx and Vy? What is Vx and Vy? Vx and Vy is the velocity of these two camera, velocity of this camera after launch for 2 seconds later. This first camera, I think halfway coming down, 2 seconds. At the moment when it's coming down, what speed is coming down? That's your Vy. Okay. When this second camera, when it's 2 seconds, maybe somewhere here, okay, after already passes the second half, at this moment, what velocity is traveling? This is your Vx. If you know the Vx and Vy value at 2 seconds, you can find the V, the speed of the object. Okay, now the question is, this is the question 4, find the V. You are looking for V, okay? You're looking for V after 2 seconds. So to find the V, find Vx and Vy. Okay, first, what is Vx value? Anyone? Anyone know the Vx value? Vx value is easy. Vx value is same as Uxy. Vx is same as Ux. Why? Anyone? Why Vx is same as Ux? Because horizontal acceleration is Ax is 0. So horizontal camera does not accelerate. Ax is 0. So Vx is always same as Ux. Never speed up. It always move with a constant velocity. So Vx value is actually same as Ux. In this case, Ux is how much? Ux is 30 cos 30. So sorry, I forgot again. What is the answer for 30 cos 30? Anyone?
15.
Yeah. So you put that Ux value lah. Ux value is 30 cos 30. Okay. So 30 cos 30. Okay. Which you already calculated earlier. Okay. So Vx not a problem, not an issue. What is Vy value? That's an issue. What is the Vy value? Okay. What is the velocity of this camera after 2 seconds when it goes up and come down? What velocity is coming down? So do you have 3 information vertically? You have 3 information vertically. You have to rely on the information again. Do you know Uy? You know Uy. Uy is 30 sine 31. So Uy we know is 15. Uy is 15. What else you know? Ay we know this Ay. Ay is how much? We know it's always negative 9.81. What else you know? Time. You know the time now. We want the Vy at 2 seconds. What? So time you know is 2 seconds. Use 2 seconds. So you know U, you know A, you know time. Can you find V for me? What formula do you use? Anyone? V equals to U plus 80. Yes. Use V equals to U plus 80. Get me the Vy. Please calculate for me. What is the Vy? Uy is 15, Ay is negative 9.81, T is 2 seconds. You want to find Vy. The velocity of this camera after 2 seconds. 2 seconds means halfway coming down. What velocity is coming down? Anyone? U is 15 plus A is negative 9.81, T is 2. You will get a negative answer. Right? You will get a negative answer. What? Because Vy's velocity is going downward. So Vy, you get a negative answer. Anyone got negative answer? That means correct. Yeah, I got a chat. So yeah, the negative 4.62. So, okay. Everyone got negative 4.62 meter per second. Okay. So the Vy, you should get negative because our wave is going down. Okay, now what the question is what? Finding the V. Can you find the V now? So what is V? V squared is equals to, so V squared equals to Vx squared plus Vy squared. Okay. So Vx, you know, 30 cos 30. Vy, you know, now is 4.62. Can you find V? Okay, calculate for me, find the V. Okay, you better calculate one. So what's the V you get? How many meters per second? Better experience it today. Yeah? So it's 30 cos 30 squared plus negative 4.62 squared square root lah, right? You get your V. Anyone? Put your answer in the chat. Okay, I got answers. Okay, all three of you got 26.4. Okay, I think it's correct. So 26.4 meter per second. Okay, 26.4 meter per second. So this is the speed, velocity the object is traveling after 2 seconds. So we can exactly find what velocity is traveling at any moment. Any moment. You are looking for V, but you can find the V if you know the Vx and Vy. Okay, Vx is always same as Ux. That is not an issue. Vy is the one you have to calculate. Vy use Uy 15, Ay is always negative 9.1, T use the T time. You can find the Vy. Then Pythagoras theorem can find the V. 26.4 meter per second. Okay, it makes sense because it was launched at 30. On the top halfway, I think should be smaller than 30, so 26.2. Okay. Okay, now this is the fourth question. Okay, now I go to the fifth one. Okay, I'm going to add slowly. Okay, I rub this. Just write the fifth question here. Huh? Okay, fifth question is this. Okay, so the fifth question is find the angle. Okay, it's about angle. Find the angle. I put theta. Angle from horizontal. From horizontal. Find the angle from horizontal axis. The object is traveling. The object is traveling. Traveling, sorry, my writing. Traveling. Okay. Traveling at 2 seconds. Okay, do you understand the question? At 2 seconds here, it's going down, right? At 2 seconds going down. The question is, what angle it makes from horizontal? What angle it makes from horizontal? What is the angle? What horizontal? What is the angle it makes from horizontal when it goes down at 2 seconds? How do you find this theta? The theta is already in the diagram here itself, right? So where's your theta? This is your theta. Okay, this is the angle. This is the angle from horizontal. So how do you find that angle? I think 5 I take for you. Okay, so how do you find the angle? So use trigo, right? So I rub here. So how do you find the angle? Okay, so anyone? So you find this angle. So this angle, how do you calculate it? Number 5, the angle. The angle, you see in the diagram, you want this angle, this angle. Angle from horizontal. It's the same as angle here in the diagram. This is the angle from horizontal. The object is moving down V. This is the angle from horizontal. So use trigo. Tangent, cos, sine. Which one do you use? Anything you can use because you know all the information. I prefer to use tangent. Tangent theta. So tangent theta equals to what? Vy over Vx. Yes. Vy over Vx will give you the theta. Make sure the Vy here you put positive. Just put the magnitude only. You need to include the negative. So Vy, you know, Vx, you know, Vy over Vx, you can find theta. Shift tangent, you get the theta. Anyone? What is the angle you get? Find the angle. Find the theta from horizontal. The object travels at 2 seconds. At the moment at 2 seconds. Okay, what angle? Okay, I got answer from the chat. So it's 10.1. So all of you got 10.1 degrees. It's a 10.1 degrees. The theta is found to be 10.1 degrees from horizontal. Okay. Okay, good. So that's it. This is the quite I can say 60% of projectile movement. Okay. So if anyone like someone like to launch an object, want to find the maximum range, what speed is going to hit the target, what height is going to rise, everything can be calculated by using this Sweat equation. Okay, this is the way the scientists all are calculating when a rocket is launched. But rocket has an external force, it has its own thrust. If without a thrust it was launched, then how the range and the distance is going to hit the target? Okay, so they all calculated based on this formula. But with this values you calculated is only correct without air resistance. Without air resistance. In reality, we got air resistance. Okay, if you consider air resistance, this value all going to be slightly slightly different, right? Okay, tell me. Let me check. If you consider air resistance, what happened to the maximum height it rise? Greater or smaller than you calculated? Will be shorter. It will be shorter. The air isn't going to block you faster. So the total time, the maximum height will be shorter. Okay. The range will be
Shorter too.
range also will be shorter. Both shorter. Okay, both shorter. In one pass here, they asked to draw. This is the original path without air resistance. With air resistance, how the path going to take? The path going to take like shorter, like this. Okay, like this. At the beginning going to be a little longer, then later going to be very short because very big air resistance. So we can't move forward like earlier. So this is with air resistance. With air resistance, we cannot calculate the numbers, but we only can calculate, you can show the trajectory only. That's how it works. Please remember, with air resistance, maximum height shorter, range shorter. Okay. Okay, good. So now we can proceed to another type. So I'm going to rub everything off. So we're going to another one level. Clear all. Okay. Now we got another type of projectile movement. Another type of projectile movement is like this. An object was launched horizontally from a certain height with a speed of, let's say, u as 30 meter per second. Okay, u as 30 meter per second. Okay, and the height it was launched is, let's say, 20 meter. Okay, the question asks, when it comes down, it reaches the ground, what is the time taken for it to reach the ground? What is the time it takes to reach the ground? Okay, so this is another type of projectile movement. This was launched horizontally and come down. It's half of the projectile movement. Again, we're going to visualize like a two camera here. Okay, visualize it as a two camera. Okay, where's the two camera? Let me change color. Okay. So where's the two camera? One camera is here. Okay, the one moving horizontally, taking the picture of the object when it could fall down. Another camera in this case is like moving. Another camera is like here, actually in front, like moving down and taking the picture. Okay. Okay, these two camera speed, we're going to break them into what? Vertical and horizontal. Okay. So tell me, we still want to take upwards as positive. As I said, I don't want to change this law to avoid confusion. Upwards as positive. Therefore, AY will be how much? Anyone? AY always negative 9.81. Never change. AX will be how much? Always never change. Is 0. I already told you why AX 0. Horizontal component of the force is 0. Therefore, horizontal acceleration is 0. Okay. Okay, now, can you find what is the total time taken? Okay. You need to know the UY and you need to know the UX. Okay, tell me. UY, what formula do you use? Cos theta or sin theta? Last time UI is the angle you're going to use is the angle between the what? Angle between the launching and the horizontal axis, you know. For this case, theta how much? Anyone? What is theta here? The theta is the angle between the launching point, launching direction and the horizontal axis. What is the theta here? Theta here is, anyone? It's 0. Theta here is 0 degrees. It launched horizontally one. So this launched horizontally, the angle becomes 0. The theta is 0. So there is no angle in between horizontally. So theta is 0. So UI is always what? U sine theta, but in this case is U sine 0. So U sine 0 how much? Sine 0 is 0, right? So UI for this case is how much? 0. UI is 0. Put in your mind, anything launched horizontally, the vertical speed, the camera going down, the vertical speed, the initial vertical speed will be 0. It will be 0 because theta is 0. Okay. What is your UX will be? UX is U cos 0, right? U cos 0 means cos 0 how much? Cos 0 is 1, you know, right? Cos 0 is 1, right? So UX going to be exactly same as U. So in this case, U is how much? 30 meter per second. The horizontal camera want to take a picture moving horizontally. Its speed also will be 30, you know, like it's going 30, this also will be goes move 30. So UX is exactly same as U, which is in this case is it's 30 meter per second. Okay. So horizontal launch is slightly different from the normal launch because angle is not given. You should know the theta is how much? Horizontal launch is 0. UI will end up getting 0. Your UX will be same exactly as U, 30. AY, AX, no differences. AY is always negative 9.81, AX is 0. Okay. Okay, now can you find the total time now? How do you find total time? Do you go vertical or horizontal? Which side you got 3 informations? This 20 meter is what information?
Height.
SY or SX? This 20 meter. It's your SY. So SY is 20 meter. Okay, now there is a trap. You put positive 20 or negative 20 here. Anyone?
Negative.
Yeah, good. Negative 20. You put negative 20 because it is displaced down. You take upwards as positive. So displaced down, negative 20. Okay, good. I think you got the 3 information. You know UI, you know AY, you know SY. I think we can park the T here. You can find the T here. So what is the time taken to reach the ground? So S equals to UT plus half AT squared. We can find the T. All we use Y component. All we use Y component. Okay. So please, someone can work out for me. What is the time? You will get to half AT squared. Sorry, half AT squared. So U is 0. U becomes 0. I think UT Don't have any more. So T is going to be finally what? Okay, so I got answer. Good. 2.02 seconds. So 2.02 seconds. I believe all of you got this. 2.02 seconds. If you got a different answer, you just put it in. We can discuss. Hey class, so I'm just teaching you the technique. Okay, the technique here is horizontal launch. Theta, remember 0. Uy going to be 0. Ux going to be same as u. Okay, ay negative 9.1, ax 0, no change. That's why it's negative 20 because going down. They can find t. So 2.02 seconds. So something launched with 30 meters per second, 20 meter height of a building, let's say a car or something, just falling down with a 30 meter per second, horizontally launched 20 meter. It's going to reach the ground at 2.02 seconds later without air resistance. Okay, now tell me, now totally yours. What is how far away from horizontal is going to reach the ground? Okay, your turn. Look out for me. 1 minute for you. Use check. You want to go for horizontal or vertical? Check 3 information. You have 3 information. Then try to work out. 1 minute for you. Come on. Give me the answer. What is the horizontal displacement? And the car or the object which is launched 30 meters per second come down to the ground after 20 meter vertical height of traveling. Okay, so I got answer. See, 60.6 meter. Check here, 60.6 meter. Okay, everyone got 60.6 meter. Okay, let's see. So you go horizontal. Okay, there is a nuances. Yeah, good. 2 of you got 60.6 meter. So I think should be correct. So I think you have to go for horizontal. You must go for horizontal. No doubt about that. You have to go for horizontal. So why horizontal? Because horizontal distance experienced by the horizontal camera. So you're looking for Sx. So Sx equals to, you're looking for Sx. You have 3 information. You know Ux, you know Ax, you know Ax, you know Ux, you know Ax, sorry, Ax. But now you know the time. Yeah, you know the time now. You know the time. The time we just calculated. The time you know is 2.02 seconds. So use Sx equals to Uxt. You don't need to write the Lanax part because Ax is 0. So just stop here. Sx equals to Uxt. You can find the Sx one. Okay. So the answer was how much? It's 60.6. Okay, 60.6. So 30 times, of course, 2.02. 30 times 2.02. So 60.6. 60.6 meter. Okay, good. So anything launched with this direction, the range is going to be 60.6 meter. Okay. So we can analyze all type of projectile movement. Only 2 type. They are launched horizontally, they are launched vertically, like just now the earlier. These are the 2 common example will be. Okay. Okay, let me go to the PowerPoint now. Okay, in the PowerPoint we have more questions. Okay, another 1 question, then 1 or 2, then we stop. Okay, today is like a heavy stuff. You learn a lot. Choose new stuff. Okay, I go back to the PowerPoint. Everyone can see the PowerPoint, right? Cannot. Okay, let me. You can see the PowerPoint. Okay, so this is the projectile motion. Okay, so only force acting upon the force is gravity. The only force acting in the projectile motion, remember, only gravity. The force is straight acting downwards. No other force is acting in the projectile movement. Okay, so the golf, soccer, bullet, and everything. So these all are projectile movements. So the rocket is launched horizontally. The only force acting down is the gravitational force. Two components of the projectile velocity, Vx and Vy, as I said, you have to break into components. Okay, horizontal component does not change. Vx remains constant throughout the flight. Okay, why? The reason I told you, the horizontal component of the weight is 0. Therefore, the Ax becomes 0. So Vx 0. Vx no change. Okay, we talk about the horizontal component of the force becomes 0. So Ax 0. Therefore, Vx remain constant. Okay, this diagram beautifully explains how the Vx change and Vy change. When it goes up, Vx no change. Vx, you see the length of the vector quantity is always the same. So Vx no change. Vy will go, when go up, you see the vertical, the value magnitude becomes shorter. At top, Vy becomes 0. Okay, remember when an object is thrown in projectile movement, when go to the top height here, maximum height, do the kinetic of the object 0 or it has a certain minimum value? Anyone? 0 or it has a certain minimum value? Is it still moving at the top point?
It is still
It's still moving. Yes, it's still moving.
at the dimension.
Yeah. So at the top, it's still moving. What velocity is moving at the top here? What velocity is the v? What v is moving? V is what? Root of vx squared plus vy squared 1. Okay, vy squared. But at the top, which v becomes 0? The vy become 0 and all. Only the vy become 0. The vertical component becomes 0. Vx still alive, got some value. So therefore, the final velocity of the object is actually going to be same as what? Same as Vx. Okay. Let's say one example I give you, the 30 meter per second, 30 degrees. Okay. Your Vx got certain value, 8.66. That means on the top, the velocity is still traveling is 8.66. It's like 8.66. 30 cos 30, is it 8.66? So if we got 8.66 meter per second, then at the top is still moving. So this is something new. Last time you throw an object up, one-dimensional movement. When go to the top point, V becomes 0. So stop moving. Okay, but projectile motion, you launch like this and come down. At the top, imagine, don't think you stop moving. It's still moving at the top. The V moving is exactly same as Vx. Okay, so don't say it has a 0 kinetic energy. It has a minimum kinetic energy. That's the correct term. There is a minimum kinetic energy. How much is the kinetic energy it possesses here? Half m, which we use Vx squared. You must use the x component value, Vx. How we know Vx is same as Ux, right? So you can put Ux also, half m use Ux squared. This is the kinetic energy at the top. Okay. Okay. So I hope you clear. Yeah. Okay. So this is how the plane package is dropped. A package follows from a parabolic path, remains directly below the plane. A plane just dropping a package. The horizontal velocity is constant, but the vertical velocity changes, getting faster and faster. Vy is increasing. Vx is always same. Okay, so these are the questions used. I skip this. Okay. Okay, one question for you. Okay, this is the last question. Get me the answer. Oh, sorry, another one we can go. Okay, this question. Get me the answer. The stone is thrown from the top of a vertical cliff with a height of 40 meters and initial velocity is 10 meters per second in horizontal direction. Now the question is, okay. So I want you to find the range. Can you find the range? What is the range it takes? Calculate the range. So you see this working, this is the not the style I want you to follow. but you can follow this style also if you want. Here, the calculation is based on taking downwards as positive. Normally, a calculation I ask you to take what? I take upwards as positive. Therefore, AY is, we choose how much? Negative 9.81. I think you can stick with this idea. You no need to use this one. Both going to give out with the same answer. It's your choice. But I think I don't want any confusion. We can stick with this. Upwards, take it as positive. And show me the calculation. What is the range you're going to take? So it was launched horizontally with 10. Anyone get the range? 1 minute for you. So what do? You find the AY is what, AX is what, UY is what, UX is what. If anyone got the answer? So horizontal launch, you want to find range. Okay, so I got answers. That I got 81.5. Yeah, 81.5. All of you got 81.5. You got 85.5. The SX value. So you're looking for SX, vertical, horizontal. So you know UX is same as 10. AX we know is 0. Another one information is the time. Time you have to get it from the vertical, no choice. So you have to calculate the time from vertical. Vertical has 3 information. What are the vertical informations? You know, UI how much? UI is 0. Horizontal launch UI is 0. AY is what? AY is negative. Here we take upwards as positive. So AY we take negative 9.81. If you follow the PowerPoint, if you take downwards as positive, then AY you must take positive 9.81. Choice is yours, but I want you to fix with one law. We always fix upward as positive. Then SY we take as what? Negative.
Positive.
So you get the time. After you get a time, you use the time here, horizontal, then you can find the 81.5. Let me check more answers was in the chat. All of you got the same answer? Oh, 28.6. Sorry, I'm wrong. I saw wrongly. Yeah, 28.6. Sorry, it's 28.6. So 28.6. Okay, all of you got 28.6. Okay, so this is the idea. So everyone got 20.8.6. Yeah, okay, good. 3 of you give me 28.6. I trust you. So 28.6. So this is how you analyze. You go vertical, horizontal, put AY negative 9.1, AX 0, UI, UX, put first, then check which side got 3 information. You just proceed. Most time the culprit is the time. Time normally you only able to find from vertical most of the time. Not always. Most of the time the time will be recovered from vertical. There is sometimes you can recover the time from horizontal. Sometimes, okay. If they give the range, then you can find the time from horizontal. Okay. Okay, class. Okay. So before we wrap up, last question, then we stop. Okay. The last question. I go to one pass here. Sorry. So this is how long it takes to reach the ground. We calculated, cut down X and Y. So we got the answers. It's working. Okay. The last question for today. Come on. Give me the answer for this. 2 minutes, then we stop. Give me the final answer. The projectile is launched with an initial speed of 30 meters per second. It makes an angle of 60 degrees above the horizontal. Find the magnitude and its direction of its velocity after 2 seconds. So how do you work out? 2 minutes for you, come on. Put vertical, horizontal, all the information you have. AY negative 9.81, AX is 0. Find the UY, UX. You're looking for what? You're looking for V, right? Looking for V at 2 seconds. So you're looking for V. I don't know the V 2 second, is it already past the first half or second half? I'm not sure because we need to find the total time. Then only know is first half or second half. I think I just put here first now. I think the V, let's say here V means we are looking for the V. So you know how to find the V? You need to find the Vx and the Vy at 2 seconds. Okay, work out for me. You need to find Vx and Vy at 2 seconds. So split into two, put vertical, horizontal, gather your informations, get your Vy and Vx for both sides. Then you can find the V. I believe you remember how V, Vx, Vy is related. Pythagoras, right? Then you can get the V. Okay, check. Do you have three informations here to find your Vy? Vx, I think shouldn't be a problem. Vx is same as Ux, but they never change. Put your answer in the chat. Okay, let's see who can. If most of you give me the same answer, then I think should be okay. Okay, so anyone able to get the answer? Find the V, So find your Vy and Vx. So Vy, we have three informations for Vy. You know Uy, I think Uy is how much? Uy is U sine theta, right? Ay is negative 9.81. You take upwards as positive. Then what? Then oh, you know Uy, you know Ay only. Uy, Ay. What else you know? Oh, time. You know time. Oh, time. You know already. Time. Oh yeah, you know the time already. What? 2 seconds. So you can find a Vy, right? You can find a Vy. Okay, I got the answer. So let's see from the chat. I hope everyone got the same answer. Your friend, 26.77. Do everyone got 26.77? Your V. 26.77, so 26.8. Everyone got this answer? You get your Vy, get your Vx. Your Vx is same as Ux. In this case, 30 what? 30 cos 60, right? 30 cos 60. So Vy, Vx. Then you do the Pythagoras, V squared equals to Vy squared plus Vx squared, what? Then you can find the V already. So I believe everyone got 26.8. Okay, as we see, so the x, Vx is same as Ux. And y, you find the Vy is q sine theta negative gt. Find the resultant of x and y components. Okay, so 26.8, everyone got 26.8, So this is the technique to find your V. Others got the answer? Okay, class, so hope you understand today's lesson. Today's lesson is something new, two-dimensional movement, projectile movement. You must break into one component, vertical, horizontal. Why we do that? Want to make use of the Soviet equation. AY always negative 9.81, AX always 0. We always take upwards as positive. The way we are doing in our class. You can take downwards as positive, but we standardize it. We go always upwards as positive. Therefore, AY is always negative 9.81. Displace down, negative. Velocity downwards, negative. Okay. So I got another one answer. Hope you got the same one. Different one, then we have to argue. Oh, okay. Another one said got 16.3. Oh, many got 16.3. Okay, please check. I think most of you got 16.3. Okay. So the answer to be, I think many got 16.3. Okay. So, okay, because we follow the majority, I think the answer is 16.3. Please try your working. 16.3 meter per second. Okay, I think your Vy, check your Vy. Check your Vy, Vx is 30 cos 60, Vy is time is 2 seconds, gravity is negative 9.81, and S5 is negative 8. Okay, I think majority is 6.3. So we go for 16.3, the answer here. Okay. So before we stop here, what I want you to do is, as a homework, please give a try the next questions. Okay, the next class we will be discussing. Sorry, let me clear this. Okay, the next question is this one. Launching from a certain height goes down. I want you to try this question. Then these few exercises. So you have about 5 exercises, about 7, 8 questions. You have 8 questions. This is going to be your homework. So tomorrow, maybe I call 1 or 2 of you. Maybe you can annotate on the paper. Okay, on the question we can discuss. Okay, please keep try 1 to 8 today. We discuss tomorrow. Any questions? No questions, Okay, guys, so we stop here. So I see you tomorrow 10 o'clock, right? Okay, if you don't have any questions, I stop here. Okay, see you then. Thank you.